Welcome to my introduction to Blender topology. In this video, I will show you examples of topology and ways it can improve your 3D models. Here we have 3 cubes with different topology, each marked red, blue, and green cat face. Now let's take a look at these 3 objects in wireframe view. As you can see, these objects are constructed very differently despite all being cubes. Some objects are very complex, while the third is very simplistic in construction. Now we can take them into edit mode to explore the properties of their topology further. Here I will move the vertices on each object. First we will edit the red cube, whose topology is very strange. The irregular shapes of faces makes it harder to edit and work with. When we try to extrude the faces of this cube, we will get a somewhat regular result. However, it is editing the vertices individually that will cause us the most trouble.
God, bro. Oh, hell no, man. What the fuck, man? Get your ass on, bro.
It is not a desirable topology to edit mesh with. Next is the blue cube, whose topology has been subdivided and triangulated. Moving vertices here results in not only irregular changes, but also too small of an area being edited at once. Finally, we have the green cube. Its topology is simplistic and clean. Movements of the vertices and faces are proportional to the shape because of the optimized topology. In comparison, the other objects in this scene are much harder to work with. Now, let's explore how modifiers in Blender react to our different topology examples. I will be adding a subdivision surface modifier. This modifier is very commonly used throughout 3D modeling to make your models look smooth. The objects have each reacted very differently to the modifier. When we take a closer look at them, we can see the triangulation on the blue cube has created an irregular jagged shape. The red cube's strange vertex layout has also led to distortion of its shape. Here we see that the distortion continues and gets worse with more subdivision steps. In comparison, the cube with the cleanest topology subdivides evenly and smoothly, with its subdivision steps being predictable. Despite more subdivision being applied to the blue cube, its jagged shapes stay. The last thing I will show you an example of is topology affecting the UV of the model. Let's try and UV edit, or unwrap, the blue cube. We can see that there is a large number of faces where our model is just a flat plane. This is very inefficient topology for our needs in UV editing. Each side has too much geometry in places that it is unnecessary. The red cube's odd topology creates unique problems while UV editing. When we select the faces to UV unwrap them, they appear normal in the UV view. This all changes when we go to create a texture using our new UV. With the texture applied to the red cube, we can see the distorted appearance of the X that I drew. When comparing it to the original drawing, it becomes apparent how much the topology of the cube changes the way the texture looks. I even tried drawing on it some more to see what would happen. I hope this video demonstrated some of the properties of topology and the reason proper topology is important to constructing 3D shapes. Messy or irregular topology can create a domino effect on your 3D models, so it's important to start off with clean topology when you begin creating.
Fast food restaurants be like